Linear systems word problems. The question here says, Angelo has a drawer full of black and white socks. There are a total of 31 socks in the drawer. Half the number of black plus 1/3 the number of white is 14. How many of each color does he have? So what we're going to try to do when we're solving a word problem is we're going to try to break it down using the GRASP model of problem solving. So GRASP stands for given, required, analysis, solution, and present. So we're going to work our way through each of these steps to help us solve the problem. So given means we're going to start by reading the question, thinking about what information it gave us, and I'm going to write that down. So I'm going to break this down by doing a little G here, and I'm going to think about what the question told me. So it tells me that Angelo has black and white socks, right? And there's a total of 31 socks in the drawer. So that seems important to me. So I'm going to write that there's a total of 31, right? The other thing it tells me is that half the number of black plus 1/3 the number of white is 14. So half the number of black means if I take the black and divide it by 2, and I plus add 1/3 the number of white, so that would be white divided by 3, I get 14. Right? And then it says how many of each color does he have? So really what's given to me is that he has 31 socks, half the black plus 1/3 of the white is 14, and I have black and white socks, but I think I'll remember that part. So next step is R for required, and that just means what is the question asking us to find? So the question, usually a good place to look is the last sentence. It says, how many of each color does he have? So the question is asking, how many black socks, how many white socks? Right, analysis. This is the tricky part. So in the analysis part, what we're going to do is try to think about what we can do to figure out the answer to the question, right? So the question is asking how many black socks, how many white socks, and I have to try to figure that part out, right? So what I'm going to do is make myself a little flow chart to help me figure out what steps I'm going to follow to figure out how many black and white socks there are. So I'm going to start at the top by saying I want to know how many black and white socks. That's kind of the top question here that I'm asking, right? So how am I going to figure out how many black and white socks there are? Well, this whole unit has been about solving linear systems. So odds are we're going to figure it out by either doing substitution or elimination, since that's what we've been spending most of this unit doing. But in order to do substitution or elimination, what do I need, right? In order to do substitution or elimination, I need two equations. So I'm going to need equation number 1 and equation number 2. Now, where are these equations going to come from? Well, in the original question, it gave me some information. It told me there were a total of 31 socks. And I feel like I could make an equation using that. Right? And my other equation, I think, is going to come from the fact that half the number of black plus the third the number of white is 14. Right? So if I do black divided by 2 plus white divided by 3 equals 14. Right? So this is just my analysis. It's a little plan to help me figure out what I need to do to solve the question. So we want to find how many socks. How are we going to do that? Substitution or elimination, because that's what we've been learning in this unit. We could also solve by graphing, but there's no grid on this question, so it's a pretty safe bet we're not going to use it. So to do substitution or elimination, I do need to have two equations. One equation is probably coming from the fact that there are 31 socks, and the other one should come from that comparison about the blacks and whites and the fractions. So that's just a little guideline to help us figure out where we're going. So the solution, this is where we actually do the math. So I like to put my solution over here on this side. And in order to solve one of these problems, you need to introduce some variables. And if we're going to introduce some variables, we need to do some let statements. So I'm going to let something be the number of black socks and let something be the number of white socks, because that's what we're trying to solve for. Now, you could try to find one way of expressing both of these in terms of the same variable. So let x be one of them and then try to find the other one in terms of x, which is what we would have done in grade 9. So we're going to try something a little bit different here. When we do substitution and elimination, we do use two different letters. So what I'm going to do is let one letter be the number of black socks and let one number be the number of white socks. So I could do B for black and W for white. We could do X and Y if you like, or really any letter combination you like. I think I'm going to do B for black and W for white. So there were two pieces of information given in the question. One of them is that there's a total of 31. So I'm going to say that the number of black plus the number of white equals 31. And then the other thing was that if you take the number of black divided by 2 plus the number of white divided by 3, it equals 14, right? That was what we wrote in our given. That's what we wrote here in our little plan. So I'm going to say that the number of black, which is B, divided by 2, plus the number of white, W, divided by 3, equals 14. So from here, I need to solve. I can use substitution, I can use elimination. I have to say one of the things I'm not really excited about are the fractions here. So I think I might try to get rid of the fractions by multiplying by something that all the denominators go into. So I have a denominator of 2, a denominator of 3, and a secret denominator of 1. So I am going to multiply this equation by 6. That's what 2, 3, and 1 would all go into. And I'm going to end up with 6b over 2 plus 6w over 3 equals 14 times 6, 84. Now 6 divides by 2 nicely, I get 3b. 6 divided by 3 is 2w, and then that 84 is just 84. So I have b plus w equals 31, and 3b plus 2w equals 84. And I need to, using these two equations, find a way to solve. So substitution, elimination, it's entirely up to you. Now I do notice that this one has a b and a w that don't have coefficients, so we could do substitution fairly easily, or we could just line them up and do elimination. It really doesn't matter. I think I might try substitution on this one. So I think I'm going to rearrange for B. So I'm going to take that W to the other side. And then I'm going to substitute this into here. Everywhere I see a B, I'm going to put in 31, take away W. So I get 3 times 31, take away W, plus 2W equals 84. And then I need to multiply out the brackets. So 31 times 3 is 93. 3 times negative W is negative 3W plus 2W equals 84. Now I have some like terms. The negative 3W and the 2W are like terms. So negative 3 plus 2 is negative 1W. And then I just need to solve for W by taking that 93 to the other side. So that minus sign belongs to W. So that's a positive 93. So I'm going to subtract 93. And a really easy mistake is to drop the negative, but this is a negative W. And 84 take away 93 is negative 9. And our last step is to divide by the little negative 1 that's hiding in front there. And negative 9 divided by negative 1 is 9. So W equals 9, which means there should be 9 white socks. So that's what that means, right? W is the number of white socks. I need to now take that 9 and come back up here and calculate the number of black socks. So I'm going to put the 9 back in. So I'm going to say B equals 31 take away 9. And 31 take away 9 is 22. Right? So we have 22 black socks and 9 white socks. So last step, right? We did G, R, A, S, and the last part is the P, which stands for present. That just means you're going to present your answer in a sentence. So we're going to finish off by actually answering the question. So how many of each color does he have, right? That was the required, how many black, how many white. So therefore, Angelo has 22 black socks and 9 white socks. And that's a linear systems number problem.